In today's class and video, we are going to look at how to measure the concentration of an unknown sample using the spectrophotometer. So first of all, what we have to note is that the measurement of concentration of a given substance requires a blank and a series of standards. And these blanks are samples with precisely known concentrations that are used as a reference to determine the concentration of the unknown sample. And to measure the concentrations of the unknown sample using the spectrophotometer, the first thing to do is to prepare your samples. The next thing is to calibrate the instrument with your blank. The next is to select the appropriate wavelength from your standard operation procedure. The next thing is to measure the absorbance of your samples. And the final thing is to calculate or determine the concentration of the unknown sample, either by using the Beer-Lambert's law or a calibration curve or a standard curve. And what we also have to note here is that if the molar absorptivity and the path length of the light are given, then the Beer-Lambert's law can be used to calculate for the concentration of the unknown sample. Otherwise, a calibration curve or a standard curve is needed to calculate the concentration of the unknown samples. Let's now see the various steps involved in the procedure for measuring the concentration of an unknown sample. So the first step is the sample preparation. The second is the calibration of the spectrophotometer. The third is the measuring of the absorbance value. And the fourth is the calculating of the concentration for the unknown sample. So let's look at the first step or process involved in the procedure for measuring the concentration of an unknown sample. So the first process is to prepare your sample, and in the sample preparation we will have to prepare our test sample, our blank, and in some cases the standard. So if you want to prepare our test sample, we subject the sample to the standard operation procedures given. So once we are done with the preparation of the test sample, we have to prepare our blank. And what we have to note is that the blank is a solution containing all the constituents used in the analysis except the substance, which is the analyte, to be measured. And the blank is prepared by using the same reagents and procedure as the sample, but without adding the analyte. And the importance of the blank is to zero or calibrate the instrument. So let's see an example of how to prepare our blank. So example, so if our sample, which is the egg albumin, is prepared in 5 ml alkaline solution and 0.5 ml falling staccato and incubated for 30 minutes, then our blank will be the mixture of the 5 ml alkaline solution and the 0.5 ml falling staccato incubated for 30 minutes. So from the cuvette over here, so we can see that this is our test sample and this is our blank over here. So the difference between the color of our blank and the test sample will be as a result of the egg albumin, which is our test sample, that will react with the alkaline solution and the falling staccato to give this blue color. So once we are done preparing the test sample and the blank, we have to clean and fill our cuvette to about 3/4 or 75 to 80% of the full length of the cuvette with the blank and the test sample solution. So the level of our test sample and the blank in the cuvette is about 3/4 or 75 to 80% of the full length of this cuvette seen over here. So let's look at the second steps or method involved in the procedure for the measuring of the concentration of the unknown sample. And this is the calibration of the spectrophotometer. So to calibrate the spectrophotometer, the first thing to do is to turn on the instrument and allow it to stand for at least 15 minutes, as this helps the instrument to warm up and to obtain a steady temperature before used. So once we are done with this, we select the wavelength by choosing the appropriate wavelength stated in the standard operation procedure for the analysis. And once we are also done with this, we zero the spectrophotometer by using the blank solution prepared to set the absorbance value to 0. So let's see how we can zero the spectrophotometer. So to do this, we place the blank solution already prepared in the cuvette and insert it into the spectrophotometer. So this is our cuvette containing our blank solution that is being inserted into the spectrophotometer over here. So once we are done with this, we use the instrument 0 or blank function to set the absorbance reading to 0. And what we have to note is that every spectrophotometer has a 0 or a blank function key that can be used to set the absorbance reading to 0, or in other ways that can be used to 0 or blank the spectrophotometer before used to measure any test sample. Look at the third method involved in this procedure, and which is the measurement of the absorbance value. So to do this, we insert the cuvette containing the test sample into the spectrophotometer as shown over here. So this is our spectrophotometer and this is our cuvette containing our test sample inserted into the instrument. And once this is done, the spectrophotometer will measure the absorbance of the test sample at the selected wavelength and display the result on the meter board of the instrument. So this is the meter board of this spectrophotometer, and this is the absorbance value obtained for this test sample, which is 2.0. What you also have to note is that before we record this value, we have to wait for 10 seconds for the result to be stable before we record. And one key thing that we also have to note is that we have to repeat the measurement twice or more for each sample and average the readings for accuracy. So let us look at the fourth and the final method in the procedure for measuring the concentration of the unknown sample. And this is the calculation of the concentration of the unknown sample. And this can be done either by using the Beer-Lambert law or the calibration curve. So we'll start by looking at how the Beer-Lambert law can be used to calculate or determine the concentration of the unknown sample in our test analysis. So first of all, what you have to note is that the Beer-Lambert law states that absorbance is directly proportional to the concentration of the analyte and the path length of the light beam through the sample. So mathematically, the equation is given as this, where this is the molar absorptivity. So if you want to find the concentration of our test sample, we rearrange the equation to be C equals this and substitute into the new equation the known molar absorptivity, the path length, and the measured absorbance value obtained from the test analysis to calculate the concentration of the unknown sample in the test protocol. So this is the first way by which we can calculate for the concentration of our unknown sample in our test analysis using the Beer-Lambert law. Finally, let us look at the second method or ways by which we can calculate the concentration of our unknown sample in the test analysis, and this is by the use of the calibration curve. So what we have to note here is that the calibration curve is created by plotting the absorbance values of the standard samples on the y-axis against their known concentrations on the x-axis. So from this calibration curve, so we can see that the absorbance values of our standard samples are plotted on the y-axis against the unknown concentrations on the x-axis. And one key thing that we also have to note is that these standards with the unknown concentrations are subject to the same standard operation procedures used for the test sample and the blank before plotting. And the calibration curve is used to determine the concentration of the unknown sample by using the equation of the line, which is given in the form of y is equal to ms plus c. So as you can see from this calibration curve, this is the equation of the line, which is given as y equals 0.3943s plus 0.1048. So where y is the absorbance values, the 0.3943 is the slope, the s is the concentrations on the x-axis, and the 0.1048 is the intercept on the y-axis. So let's assume that in our test analysis, we had the absorbance value for the test sample to be 0.5. So if you want to calculate the concentration for this test sample, we will substitute the 0.5 in place of the y in the equation of the line, and we make s the subject. So the value that we will obtain, or we will get for the s in the equation of the line, becomes the concentration of our unknown sample in the test analysis.